प्रिव्हियस लेक्चरमध्ये आपण डेरिव्हेटिव्ह ऑफ कंपोजिट फंक्शन पाहिला होता. त्यानंतर डेरिव्हेटिव्ह ऑफ कंपोजिट फंक्शन्समध्ये सम स्टँडर्ड फॉर्म्युलाज ऑफ डेरिव्हेटिव्ह ऑफ कंपोजिट फंक्शन्स पाहिले होते. त्यानंतर कंपोजिट फंक्शनवर क्वेश्चन 1 आणि क्वेश्चन 2 वेगवेगळ्या प्रकारचे फंक्शन्स घेऊन त्याला डिफरन्शिएट करून डेरिव्हेटिव्ह फाइंड आउट केलं होते. त्यानंतर आपल्याला डेरिव्हेटिव्ह ऑफ कंपोजिट फंक्शनमध्ये एक वेगळा पार्ट लर्न करायचा आहे. फंक्शन कंपोजिट फंक्शनच्या टाईपमध्ये राहील, फंक्शन थोडंसं मोठं राहील आणि फंक्शन जे राहील तुम्हाला दिलेलं ते लॉगॅरिथमिक फॉर्ममध्ये दिलेलं राहील. जर तुम्हाला लॉगॅरिथमिक फॉर्ममधलं कुठलंही डेरिव्हेटिव्हचं एक्झाम्पल सॉल्व करायचं असेल तर आधी तुम्हाला लॉगॅरिथमिक रूल्स माहिती पाहिजेत. इफ यू नो अबाउट द रूल्स ऑफ logarithm, then you can solve the examples of derivatives and the examples of derivative of composite function which is in the logarithmic form. If the rules of logarithm is if m and n be two different functions, then the first rules of logarithm is log of m raised to the power n is equals to n log of m. Next one, if m and n again two different function and m and n is in the product form, then log of m into n is equals to log of m plus log of n. Third one, if m and n are in the quotient form m upon n, then the log of m upon n is equals to log of m minus log of n. If m and n is in the form of base, means if the given function is log of m base n, then log of m base n is equals to log m upon log of n. Next one, clearly we know that the value of log e is equals to 1 and the value of log of 1 upon m is equals to minus log of m. हा रूल्स इनडायरेक्टली तयार होतो. लॉग ऑफ 1 बाय m ची व्हॅल्यू मायनस लॉग ऑफ m कशा प्रकारे आली याचं प्रूफ मी तुम्हाला देऊ शकतो. जर तुमच्या जवळ फंक्शन लॉग ऑफ 1 अपॉन m दिलेला आहे तर डिनॉमिनेटर मध्ये असलेला 1 आणि त्याचा पॉवर प्लस 1 आहे. आपण जर राईट साइडला लिहिताना याला लॉग ऑफ हा m न्यूमरेटर मध्ये शिफ्ट केला तर तुमच्या जवळ असलेला m चा पॉवर पॉझिटिव्ह न्यूमरेटर मध्ये घेतल्यानंतर निगेटिव्ह मध्ये कन्वर्ट होतो. अँड वी नो दॅट log of m raised to the power n is equals to n log of m. जर तुमच्या जवळ फंक्शनचा पॉवर लॉगॅरिथम मध्ये दिलेला असेल तर तो आपण लॉगच्या आधी लिहू शकतो. इट मीन दॅट जर आपण n हा लॉग m च्या आधी लिहू शकतो तर पॉवर असलेला -1 हा मायनस लॉग ऑफ m अशा प्रकारे. हेन्स वी कॅन प्रूव्ह द व्हॅल्यू ऑफ log of 1 by m is equals to minus log of. By using the rules of logarithm, we can find the derivative of composite functions which is in the form of logarithm. Next question number 3 is differentiate the following functions. The example number 1, y is equals to log base 3 of log base 5 x. The given equation or the given function is in the form of logarithm and also it is a composite function. If we have to find the derivative of this function, first we simplify this function which is in logarithmic form. We can write this function y is equals to log base 3 into log x upon log of 5. We use the formula of logarithm log of m base n is equals to log m upon log n. After that, this function log base 3 log x upon log 5, we can write it log of base 3 into log x minus log of base 3 into log of 5. Here we apply the formula of rules of logarithm log of m upon n, which is equals to log m minus log n. After that, we can write this function log base 3 is equals to log of log x upon log of 3 minus log base 3 into log 5 as it is. If we differentiate the given function with respect to x, then we can write the derivative of y is dy by dx is equals to, we take the constant function common before the derivative, d log 1 upon log of 3 into derivative of log x minus log base 3 log of 5, which is a constant function and the derivative of constant function is 0. Hence we can write the derivative of whole this function is 0. Then again we can write 1 upon log 3 as it is. Derivative of log x is 1 by x. Derivative of log x is 1 by x. Then we can write the derivative of composite function log of log x is 1 upon log x, and we take the again a derivative of log x. We know that the derivative of log x is 1 by x, hence we can write this 1 upon x log of 3 into log of x, which is a derivative of y dy upon dx. The next example of question 3, example number 2 is y is equals to log of e raised to the power 3x into 3x minus 4 whole raised to the power 2 by 3 upon cube root of 2x plus 5. If the given function which is in logarithmic form, then we can apply here the rules of logarithm is log of m upon n. We know that the log of m upon n is equals to log m minus log n. Hence we can write this function log of e raised to the power 3x into 3x minus 4 whole raised to the power 2 by 3 minus log of cube root of 2x plus 5. The given function which is log of e to the power 3x into 3x minus 4 raised to the power 2 by 3 is again in the form of log of m into n. And we can write the rules of logarithm log of m into n is equals to log m plus log of n. Hence we can write here is equals to log of e raised to the power 3x plus log of 3x minus 4 whole raised to the power 2 by 3 minus log of, and we can write cube root of 2x plus 5 is in the form of 2x plus 5 whole raised to the power 1 by 3. Now, here we convert the log of e raised to the power 3x, log of 3x minus 4 raised to the power 2 by 3, log of 2x plus 5 raised to the power 1 by 3 is 3x into log e plus 2 by 3 into log of 3x minus 4 minus 1 by 3 into log of 2x plus 5 by using the rules of logarithm, which is log of m raised to the power n is equals to n log of m. Now, after differentiating this function with respect to x, we get the derivative of y is dy by dx is equals to, here 3 and log of e is constant function. Hence we take the derivative of only x plus, again here 2 by 3 is constant function. We take the derivative of log of 3x minus 4. Again minus 1 by 3 is a constant function. We take a derivative of log of 2x plus 5. After differentiating, the derivative of x is 1. We can write this 3 into log of e into the derivative of x is 1 plus 2 by 3. The derivative of log x is 1 by x. Hence we can write it. The derivative of log of f of x is 1 upon 3x minus 4. And we take again a derivative of 3x minus 4. After that, minus 1 by 3 is as it is. Derivative of log of 2x plus 5 is 1 upon 2x plus 5 into again a derivative of 2x plus 5. After that, we can write here 3 into the value of log is again 1 into 1 plus 2 by 3 as it is into 1 upon 3x minus 4, and the derivative of 3x is 3 minus 4 is constant function and the derivative of 4 is 0 minus 1 by 3 into 1 upon 2x plus 5, and the derivative of 2 is constant, 2x is 2 plus 5 is constant function, the derivative of 5 is 0. After that, 3 into 1 is equals to 3 plus, here 3 minus 0 is 3, 2 by 3 into 3 upon 3x minus 4 minus 1 by 3 into 2 plus 0 0, 2 into 1 2 upon 2x plus 5. Here 3 cancel. We can write here 3 plus 2 upon 3x minus 4 minus 1 into 2 upon 3 into 2x plus 5, which is a required derivative of y dy upon dx. Next example is y is equals to log of under root of 1 minus cos of 3x upon 2 upon 1 plus cos of 3x minus 2. Here we know that the trigonometric function 1 minus cos theta is equals to 2 sin square theta by 2, and 1 plus cos theta is equals to 2 cos square theta by 2. By using this rule, we can write here y is equals to log of under root of 1 minus cos of 3x by 2 is 2 sin square 3x upon half of the 3x by 2 is 3 by 3x upon 4 upon 1 plus cos of 3x by 2 is equals to 2 cos square 3x upon 4. Here 2 constant cancel. Log of under root of, we know that sine upon cos is tan. Hence we can write sine upon sine square upon cos square is tan square. Same angle 3x upon 4 as it is. Here under root and square cancel. After that we can write it log of tan of 3x upon 4. If the given function we convert y is equals to log of tan of 3x by 2. Now we differentiate with respect to x. After differentiating, the derivative of y is dy by dx is equals to the derivative of log of f of x. Derivative of log of f of x is equals to 1 upon fx into again the derivative of fx, which is the derivative of composite function log of f of x. Hence we can write it derivative of log of tan of 3x upon 4 is 1 upon tan of 3x upon 4, and we take again the derivative of tan of 3x upon 4. Again here we know that the derivative of tan of f of x is equals to sec square f of x into again the derivative of f of x, which is a composite function, and hence we can write here 1 upon tan of 3x by 4 into sec square 3x by 4 into again the derivative of 3x upon 4. It can we write dy upon dx is equals to sec square 3x upon 4 into 1 upon tan of 3x by 4. We can write it cot of 3x by 4, and again the derivative of 3x by 4, here 3 by 4 is constant, and the derivative of x, remaining x is 1. After that we can write it sec square means 1 upon cos square 3x by 4 into cot of 3x by 4 is equals to cos of 3x by 4 upon sine of 3x by 4 into 3 by 4 into 1 is 3 by 4. After that cos of 3x by 2 cancel, here square is cancelled, hence here remaining function is 3 upon 4 into cos of 3x by 4 into sine of 3x by 4. Again we can write it 3 upon 2 into 2 sine of 3x by 4 into cos of 3x by 4. We know that 2 sine x into cos x is equals to sine 2x. Hence we can write it 3 upon 2 into 2 sine of 3x by 2 into cos of 3x by 2 is sine, and double of 3x by 2 is 3x upon 2. We know that 1 upon sine is cos x, hence we can write it 3 by 2 into cosec of 3x by 2, which is the required derivative of y, dy upon dx. Next, example number 4 is y is equals to log of under root of ex plus under root of x square plus a square upon under root of x square plus a square minus x. First we simplify this logarithmic function. Hence we can write this function log of under root of x square plus a square plus x upon under root of x square plus a square minus x. If we rationalize this function, it means that we can write here into under root of x square plus a square plus x upon under root of x square plus a square plus x. We can write it log of under root of x square plus a square plus x under root of x square plus a square plus x is equals to under root of x square plus a square plus x whole raised to the power 2 whole bracket square. By using the rules of a plus b into a plus b is equals to a plus b whole bracket square. The product of denominator, which is in the form of a minus x into a plus x, the rules of a plus b into a minus b is equals to a square minus b square. Hence we can write this function under root of x square plus a square whole bracket square is x square plus a square minus b square means x square. Here x square plus x square minus is cancelled. Again we can write it log of under root of x square plus a square plus x whole bracket square upon the value of under root of a square is a. We can write it again log of square root and square cancel under root of x square plus a square plus x minus log of a. By using the rules of log of m by n is equals to log m minus log n. Now we differentiate the given function with respect to x. The derivative of y is dy by dx is equals to, here the derivative of log of fx is derivative of log of fx is equals to 1 upon fx into again the derivative of fx. By applying this rule we can write it 1 upon under root of x square plus a square plus x, and we take again derivative of fx. It means that the derivative of under root of x square plus a square plus x minus log a is a constant function, hence the derivative of log a is 0. Now we take the derivative of under root of x square plus a square plus x. By using the rules of u plus v, we can take the derivative, separate derivative of under root of x square plus a square and plus x. After differentiating, first we can write 1 upon under root of x square plus a square plus x as it is. The derivative of under root of x square plus x is 1 upon 2 under root of x square plus a square, and we take the again derivative of x square plus a square. By using the rules of derivative of under root of fx is equals to 1 upon 2 under root fx into derivative again of fx, and the derivative of x is 1. After that we can write it 1 upon under root of x square plus a square as it is into 1 upon 2 under root of x square plus a square as it is, and the derivative of x square is 2x and a square is constant function, hence the derivative of a square is also 0. X square plus a square is 0, then we can write the derivative of x square plus a square, finally 2x plus 1 as it is. Here we can cancel 2. After that we can write it 1 upon under root of x square plus a square plus x as it is into 1 into x is x upon under root of x square plus a square plus 1. Now 1 upon under root of x square plus a square plus x as it is. Here we take the cross product of x upon under root of x square plus a square plus 1. X into 1 is x plus 1 into under root of x square plus a square is under root of x square plus a square. Again the denominator under root of x square plus a square into 1 is under root of x square plus a square. These two terms are in multiple form and the denominator of first term and the numerator of first terms are similar. Hence we cancel numerator and denominator. Then we can write 1 upon under root of x square plus a square, which is the required derivative of y, dy upon dx. The next example of question number 3 is example number 5. Y is equals to 4 raised to the power log base 2 sin x plus 9 raised to the power log base 3 cos x. First we know the rules of logarithm. A to the power log base a of f(x) is equals to f of x. And we convert these both functions is in the form of a to the power log base a f of x. We know that 4 is a square of 2. Hence we can write 4 is 2 square and log base 2 sin x as it is. After that we can write 9 3 square and log of base 3 cos x as it is. We know that log of m raised to the power n is n log m. Hence we can write n log m is log of m raised to the power n. By applying this function we can write it 2 raised to the power log base 2 sin square x plus 3 raised to the power log base 3 cos square x. We know that 2 raised to the power log base 2 sin square x is sin square x plus 3 raised to the power log base 3 cos square x is cos square x. By applying the rules of a to the power log base a f of x is equals to f of x. In a trigonometric function, the rules of trigonometric function is first rules of identity rules is sin square x plus cos square x is equals to 1. Hence we can write this function is sin square x plus cos square x is equals to 1. The value of y is 1. After differentiating with respect to x, the derivative of y is dy by dx and y is constant function. Hence the derivative of 1, which is constant function, is 0, which is the required derivative of y. Next example, example number 5, y is equals to a to the power a log base a into cot x. We know that a to the power log base a of f of x is equals to f of x, which is a basic rule for logarithm. Hence, we can write it a to the power log base a of cot x, and this whole function we can write cot x. It means that the required function y is equals to a to the power cot x, we can write it in the form of a to the power a log base a of cot x. Now we differentiate the given function with respect to x. After differentiating, the derivative of y is dy by dx. If we take the derivative of a to the power cot x by using the rules of derivative of a to the power f of x is equals to a to the power f of x into log a, again derivative of f of x, we can write it a to the power cot x into log of a into again a derivative of cot x. Before d upon dx whole term we can write as it is a to the power cot x into log of a, and we know that the derivative of cot x is minus cosec square x. Hence, this term we can write it minus cosec square x into a to the power cot x into log of a, which is the required derivative of y, dy upon dx. Here we take the next question, question number 4. F of x is equals to under root of 7gx minus 3, and given that g of 3 is equals to 4 and g dash of 3 is equals to 5, then we have to find the value of f dash of 3. Given function or the given questions is different from previous questions. Here clear that we have to find the derivative of f of 3 means f dash of 3. If we have to find the f dash of 3, then we have to first calculate the derivative of given functions. After differentiating, we can put the value of x replaced by 3 and we get f dash of 3. First we write given function, and given function is f of x is equals to under root of 7gx minus 3. If we differentiate the given function with respect to x, we get the derivative of fx is f dash of x. Here, given function is under root of 7gx minus 3. We can apply here the rules of derivative of under root of fx. And we know that the derivative of root of fx is 1 upon 2 under root of fx, and we take again a derivative of fx. By applying this rule, we can write the derivative of under root of 7gx minus 3 is 1 upon 2 under root of 7gx minus 3, and again a derivative of 7gx minus 3. Before the d upon dx whole term we can write as it is 1 upon 2 under root of 7gx minus 3. Here 7gx minus 3 is in the form of u minus v, and the rules of derivative of u minus v is du upon dx minus dv upon dx. Hence we can write it 7 is constant, derivative of gx minus derivative of 3. Again we can write it 1 upon 2 under root of 7gx as it is minus 3 into 7, and the derivative of gx is g dash of x minus 3 is constant function and the derivative of constant function is 0, hence the derivative of 3 is 0. After that we can write f dash of x is equals to 1 upon 2 under root of 7gx minus 3 into 7g dash of x. If we replace the value of x is 3, then we can write the above equation f dash of 3 is equals to 1 upon 2 under root of 7g of 3 minus 3, and 1 into 7g dash of x is 7g dash of 3. By the given condition, the value of g dash of 3 is 5 upon 2 under root of 7 into the value of g of 3 is 4 minus 3, which is given. Then 7 into 5 as it is upon 2 under root of 7 into 4, 28 minus 3 is equals to 7 into 5 as it is upon 2 into under root of 28 minus 3 is 25 is equals to 7 into 5 as it is upon 2 into the value of under root of 5 is 5. 5 cancel. Hence the required value of f dash of 3 is also 7 upon 2, which is a required solution of the given functions. Next question, question number 5. If f of x is equals to capital G of 3 of g of 5g of x and the value of g of 0 is 0, g dash of 0 is 3, and we have to find the value of f dash of 0. If we find the value of f dash, means first we find the derivative of given function f of x. After differentiating f of x, we get the derivative of f of x is f dash of x. After substituting x replaced by 0, then we get a required solution f dash of 0. By the given condition, we can write first, given that f of x is equals to g of 3 into g of 5 into g of x, bracket complete. If we differentiate given function with respect to x, the derivative of fx is f dash of x is equals to d upon dx of g of 3 into g of 5g of x. We know that the derivative of f of x is equals to f dash of f of x into again a derivative of f of x. Hence we can write here the derivative of g of whole bracket, which is in composite form, g dash of 3 into g of 5g of x. And again we take the derivative of 3 into g of 5g of x. First function g dash of 3 into g of 5g of x as it is. 3 is constant function and the derivative of g of whole composite function is g dash of 5g of x. And again we take the derivative of whole bracket derivative of 5 into g of x. Then we can write g dash of 3 into g of 5 into g of x into 3 g dash of 5 into g of x. Here 5 is constant and the derivative of g of x is g dash of x. If we replace the value of x is 0, then we can write f dash of 0 is equals to g dash of 3 into g of 5 of g of 0 into 3 into g dash of 5 into g of 0 into 5 into g dash of 0. By the given condition, value of g of 0 and g dash of 0 is given. Then we can write g of 0 is equals to g dash of 3 into g of 5 into 0 into 3 into g dash of the value of g of 0 is 0 into 5 into 0 into 5 into the value of g dash of 0 is 3. Hence again we can write g dash of 3 into 5 into 0 is 0, g of 0 into 3 into 5 into 0 is 0, g dash of 0 into 15. This constant function 15 into g dash of 3 into the value of g of 0 is again 0, 3 into 0 into 3 into the value of g dash of 0 is 3 is equals to 15 into 3 into 0 is again 0, then g dash of 0 into 3 into 3 9, 15 into the value of g dash of 0 is again 3 into 9. 15 into 9 is 27. Hence we can write whole value is 15 into 27 and the product of 15 into 27 is 405, which is a required value of f dash of 0. Hence, f dash of 0 is 405, which is a required solution, and a required value of f dash of 0. We show the next question is question number 6. Select appropriate hint from the hint basket. Spaces in the following paragraph. Activity. If by the given condition the function f of x is sin x and the function g of x is log x. Here, by the given condition, f of x and g of x be two functions. First function f of x is sin x and the second function g of x is log x. Then we can write f of g of x is, what is the value of f of g of x? F of g of x is equals to, we can write it f of g of x, f o g of x. G of x is given, the value of g of x is log x, hence f of g of x. If the x replaced by log x and the value of g of x is log x, then f of x, if the value of f of x is sin x, then f of log x is equals to sin of log x. Hence we can write here f of g of x is sin of log x. Next one, we have to find g of f of x. G of f of x means g of f of x is equals to g o f of x. The value of f of x is sin x, then it g of sin x. If the g of x is sin log x, then g of sin x is log of sin x. Hence, we can write here the value of g of f of x is log of sin x. Again, we can write the value of f dash of x. If the function f of x is sin x, then the f dash of x is a derivative of f of x. Then the derivative of sin x is cos x. G of x is a derivative of g dash of x is the derivative of g of x. Then derivative of log x is also 1 upon x. The derivative of f of g of x with respect to x in terms of f and g, we can write f dash of g of x into again derivative of composite function of function is g dash of x. Next one, therefore derivative of f of g of x is equals to, we have to find the derivative of f of g of x, f of g of x, and we can write the derivative of f of g of x is f dash of g of x into again derivative of g of x into again derivative of g of x or g dash of x. F dash of x, it means that g dash of x. F dash of the value of g of x given, it is log x, and the value of g dash of x is 1 by x. F dash of log x means if the value of f dash of x is cos x, then f dash of log x is cos of log x. Hence, d upon dx of f of g of x is cos of log of x upon x. Hence, we can write here d upon dx of f of g of x is cos of log of x upon x. After that, the derivative of f of g of x at x is equals to 1 is, if the value of x is 1, if we put x is equals to 1, then cos of log 1 upon x replaced by 1. Cos of the value of log 1 is 0, and we know that the value of cos 0 is 1. Hence we can write the value of dy upon dx of f of g of x at x is equals to 1 is also 1. The derivative of g of f of x with respect to in terms of f and g is the derivative of g of f of x in terms of with respect to x in terms of f and g is g dash of f of x into again derivative of f of x is f dash of x. Hence we can write here the derivative of g of f of x is equals to, now we have to find this value of derivative of g of f of x. It can write g dash of f of x into again derivative of f dash of x. We know f dash of x is equals to cos x and g dash of f of x is sin x. G dash of sin x into value of f dash of x is cos x. G dash of sin x, g dash of x is 1 by x, then g dash of sin x is 1 upon sin x into cos x. 1 into cos x is cos x upon sin x is equals to cos x, cos upon sin is cot x. Hence we can write d upon dx of g of f of x is cot x. If we put the value of x is pi by 3, then the value of cot of pi by 3 is equals to root 3. Hence we can write here the value of g of f of x at x is equals to pi by 3 is root 3.